Hello viewers, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be solving this beautiful integral. So we have integral from 0 to half of natural log of sine pi x over 2 dx. You can see this is a logarithmic integral, and then we have a trigonometric function there. So how do we solve this problem? Before we get started, don't forget to subscribe to my channel, like my videos, comment, and also share. Click the notification button so that anytime we upload video, you'll be the first to watch. Alright guys, so let's dive into the solution. You'll be wondering, what method are we going to use in this problem or in solve this problem? Yeah, the first thing you're gonna do is to make a substitution. But before that, I would like to introduce a very special function in calculus to us. And then what's the function? We call it the closing function. Alright, so I'm gonna introduce the closing function now. Now, remember, if you have this kind of integral, if you have integral from 0 to 2 theta, then of natural log of 2 multiplied by sine x over 2 dx. So this will give us negative, then the closing function of order 2, then multiply by 2 theta. That is this upper limit here, 2 theta. Are we together? So this is what we call the closing function of order 2. So the closing function, generally, we have closing function of order z, all right, of theta. So this is called closing function of order z. But what we'll be using today is a closing function of order 2. All right, so what are we going to do? Now, this is what we're going to do. So I said we're going to make use of the substitution so that this integral right here will look exactly like this integral. Now, how? So we're going to say let pi of x, right, be equal to, you can use any variable you like, but I will be using lambda. I love using lambda a lot. All right, so I can say let pi x be equal to lambda. So if pi x is equal to lambda, don't forget you have to differentiate both sides so that you make the x the subject of the formula. So we do that, we have pi the x, all right, is equal to the lambda. Then if you make the x the subject of the formula, so we have the x is equal to 1 for pi the lambda. And then take note, the limit will change. All right, if you put x to be 0, that will be still 0. And if you put x to be half, so that will be pi over 2, because pi multiplied by half will surely give us pi over 2. I hope we are getting it. All right, guys, so let's move on. So this will be integral from 0 to pi over 2. All right, then multiply by ln sine. All right, so instead of us writing pi x, we're going to write lambda over 2. Then instead of us writing the x, we have 1 over pi the lambda. All right, so we can bring out this 1 over pi out because it's a constant. So we're going to have 1 over pi, then integral from 0 to pi over 2, the natural log of sine lambda over 2, then the lambda. Yeah, this is pretty cool. This is cool. All right, so what are we going to do now? Now, we are going to make use of some manipulations here so that this integral will look exactly like this integral. So what manipulation are we making use of? Now, look at something. Don't forget, we have 1 over pi integral from 0 to pi over 2, the natural log. So this is what I'm going to do. I'm going to multiply this function inside the bracket by 2 and then by 1 over 2. This is what I'm saying. That is 1 over 2 multiplied by 2, then multiplied by sine lambda over 2, then the lambda. Now, this does not change anything here because 1 over 2 multiplied by 2 is still 1. Then 1 times sine half lambda, so that will give us sine half lambda. So it's not changing anything, it's just a matter of manipulation, all right? So that this integral will look exactly like this integral. I hope we are getting it. All right, so I would like to remind us the property of your logarithm. I know you remember that very well. That is, if you have natural log of a dot b, that is natural log of a multiplied by b, so that will give us natural log of a plus natural log of b. Pretty cool. Yeah, so we're going to make use of this property in this integral. All right, so let's do that now. All right, so we have 1 over pi, then integral from 0 to pi over 2, then natural log of 1 over 2, then plus natural log of 2 sine lambda over 2, then the lambda. Oh, that's wow. That's wow. Okay, guys, so now let's move on. Okay, so we can split this, that is, we can apply linearity. So if we apply linearity, we have 1 over pi, then integral from 0 to pi over 2, natural log of 1 over 2, the lambda, then a plus 1 over pi, integral from 0 to pi over 2, natural log of 2, multiplied by sine lambda over 2, the lambda. So don't forget, natural log of 1 over 2 means natural log of 1 minus natural log of 2. The natural log of 1 is 0. So 0 minus natural log of 2, that will give us negative natural log of 2. So then if you integrate the constant, you get x, or you mean we are using lambda, yes, you get lambda. So we have 1 over pi multiplied by negative natural log of 2, then multiply by lambda, then you apply your limit from 0 to pi over 2, then plus 1 over pi, then the integral from 0 to pi over 2, natural log of 2, multiply by sine lambda over 2, then the lambda. All right, so if you apply your limit here, so we're going to have pi over 2 minus 0, then this will be negative 1 over pi natural log of 2, then I multiply by pi over 2 minus 0, then a plus 1 over pi, then the integral from 0 to pi over 2, natural log of 2, sine lambda over 2, the lambda. Alright, that's pretty cool. So pi over 2 minus 0 will give us pi over 2. Then we notice that pi, we cancel out pi. So what we have now is 1 over 2, natural log of 2 plus 1 over pi. Then don't forget what I gave you the other time, the closing function. So that will surely give us negative closing function of order 2, then multiply by pi over 2, because your 2 theta there is pi over 2. All right, so we have the negative. So we have negative closing function of pi over 2. All right, that's pretty cool. So we have minus 1 over 2 natural log of 2, then minus the closing function of pi over 2 of order 2. So the closing function of pi over 2 of order 2 will surely give us the Catalan constant, because the constant Catalan constant. So let me use black marker for that. So we have the Catalan constant. All right, so and in some textbook you use G, in some textbook they use C, in some textbook they use K. So I'll be making use of G. All right, so this will be negative, and don't forget it's 1 over pi. Yeah, I forgot to put it here. So we'll have 1 over pi. So we have 1 over 2 natural log of 2, then minus 1 over pi, then multiply by the closing function. All right, so that is the answer to the beautiful problem. So therefore, integral from 0 to half, then of natural log of sine by x over 2 dx. So that will surely give us negative half natural log of 2, negative pi multiplied by the Catalan constant. So that is about that. All right, so if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and also share. Thanks for watching. See you next time. Bye.